Hello, welcome to another exciting lesson on ExamPadi. Our topic today is simplification of algebraic expression. And in this lesson, we will 1. Learn about algebraic expressions. 2. Explain using variables as symbols that represent numbers in algebraic expressions. 3. Identify like terms in an algebraic expression. And 4. Develop skills to combine like terms to simplify algebraic expressions and solve simple algebraic equations. Simplifying algebraic expressions means reducing an expression to its simplest form. This involves combining like terms, which are terms with the same variables raised to the same power, and performing operations like addition, subtraction, multiplication, and division where possible. Simplifying algebraic expression is a fundamental skill in algebra that helps students solve equations and understand more complex mathematical concepts. For instance, in the expression 3x plus 4x minus 5, you can combine the like terms 3x and 4x to get 7x minus 5, which is the simplified form of the original expression. Interestingly, algebraic expressions are made up of terms separated by an addition or a subtraction sign. Note that algebraic expressions do not have equal signs. Here are some examples of algebraic expressions. 2x plus 1, minus 3m minus 7n plus 2, 2a plus b minus 6c plus 4. What do you understand by the word term? A term can be a single number, positive or negative, a variable, or one or more numbers and variables that are being multiplied together. Terms are separated by plus or minus signs. Here are some examples of terms. 3xyz as a single term, minus 7s squared as a single term, 3xyz plus 7 as a double term, a minus b as a double term, x plus y plus 8 minus 2x minus y as 5 terms, 3pq minus 6p minus 4 plus 3q plus p as 5 terms. How do we determine number of terms? Examples. 1. How many terms does the following algebraic expression have? 3x plus 2y minus 6. Step 1. Recall what a term is. Terms are separated by an addition or subtraction sign. Step 2. Identify the plus and minus signs in the expression. You may circle the plus or minus signs to help you. Step 3. Count the number of terms on either side of the plus and minus signs. Therefore, we can say the expression has 3 terms. Let's see what it means to work with algebraic expressions. When you learned to add or subtract objects, you learned that, for example, 1 apple plus 1 apple plus 1 apple plus 1 apple can be written as 4 apples. When you started working with multiplication, you also learned that 1 apple plus 1 apple plus 1 apple plus 1 apple can be written as 4 times 1 apple, which gives us 4 apples. 2 apples plus 2 apples plus 2 apples can be written as 3 times 2 apples, which gives us 6 apples. 9 plus 9 plus 9 plus 9 can also be written as 4 multiplied by 9, which gives us 36. 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 can also be written as 7 multiplied by 3, which gives us 21. The same principles apply in algebra. However, Remember that in algebra, a letter or variable replaces a number. For example, 1. X plus x plus x plus x plus x plus x plus x equals 7 times x, which gives us 7x. 2. P plus p plus p equals 3 times p, which equals 3p. 3. Y plus y equals 2 times y, which gives us 2y. And 4. M plus m plus m plus m plus m equals 5 times m, which gives us 5m. How familiar are you with constants and coefficients? You also need to know and understand two other words when working with algebraic terms: constants and coefficients. Constants are the unchanging numbers, and coefficients are the multipliers of variables in algebraic expressions. The following algebraic expression contains two terms: minus 4x plus 5. 5 is a constant term, as the value will always be 5 and will not vary. The value of the minus 4x minus 5 term will vary depending on the value of the variable x. In the minus 4x plus 5 term, the x is called the variable and the minus 4 is called the coefficient. Here are some more examples of terms that will vary in value depending on the value of the variable. 1. P plus p plus p equals 3p. 2. Y plus y equals 2y. And 3. M plus m plus m plus m plus m equals 5m. Solution. In 3p, the 3 is the coefficient of p. We know there are 3 p's. If p equals 2, then 3p equals 2 plus 2 plus 2, which equals 3 times 2, and that gives us 6. If p equals 5, then 3p equals 3 multiplied by 5, which gives us 15. In 2y, the 2 is the coefficient of y. We know there are 2 y's. If y equals 10, then 2y equals 2 multiplied by 10, which equals 20. If y equals 1 over 2, then 2y equals 2 times 1 over 2, and 2 times 1 over 2 gives us 1. In 5m, the 5 is the coefficient of m. We know there are 5 m's. If m equals 1, then 5m equals 5 times 1, which equals 5. If m equals 7, then 5m equals 5 multiplied by 7, which gives us 35. How do we identify the different parts of an algebraic expression? For these algebraic expressions, write down the number of terms, the constant term, the coefficient of x, the coefficient of y, and the coefficient of k. Let's take a look at an example. 1. 2x plus y minus 4k minus 6. Solution. Step 1. Identify and count the number of terms, which are 2x plus y minus 4k minus 6. There are 4 terms separated by addition and subtraction. Step 2. The constant is the term without a variable. The plus or minus sign before the term is part of the constant. That is, the constant there is minus 6 and is carrying a negative sign. Step 3. To find the coefficient of x, look for the term that contains an x. The plus or minus sign before the term is part of the coefficient. The coefficient of x is plus 2 or 2. Step 4. To find the coefficient of y, look for the term containing y. The plus or minus sign before the term is part of the coefficient. The coefficient of y is plus 1 or 1. Step 5. To find the coefficient of k, look for the term that contains k. The plus or minus sign before the term is part of the coefficient. The coefficient of k is minus 4. How do we add and subtract like terms? We have seen that we can add p plus p plus p to get 3p. These three terms are called like terms because they all contain the same variable p. We can also add 3x plus 4x because both terms have the variable x. We can combine the terms using the operation that is given, which in this case is addition. The correct answer is 3x plus 4x equals 7x. We can also subtract like terms. We can simplify the expression 10a minus 2a using subtraction. The correct answer is 10a minus 2a equals 8a. When we collect or combine the like terms, we give an expression in its simplest form, known as simplifying an expression. We can add or subtract any number of like terms. For example, 4x plus 2x plus 5x plus 10x equals 21x. 10x minus 2x plus 3x minus x plus 14x equals 24x. Terms that do not have the same variables are called unlike terms. If we find an expression with unlike terms, we cannot add or subtract these terms. For example, 3x plus 3y contains two unlike terms. They have the same coefficient but not the same variable. This expression cannot be simplified further. Sometimes, expressions contain both like terms and unlike terms. To simplify an expression like this, we collect like terms. This means we arrange the terms first to group all the like terms. Then, we add or subtract the like terms to simplify the expression. Collecting like terms to simplify an expression. 1. Simplify the expression 2x plus 3y plus 5x plus 2y by collecting like terms. Step 1. Rearrange the terms so that you group all the like terms. That is 2x plus 5x plus 3y plus 2y. Step 2. Add or subtract the like terms and give the simplified expression. 2x plus 5x gives 7x. 3y plus 2y gives 5y. Therefore, we have 7x plus 5y. 2. Simplify the expression by collecting the like terms. 8x plus 13y minus x minus 4y. Step 1. Rearrange the terms so that you group all the like terms together. Keep the sign in front of each term with that term. 8x minus x plus 13y minus 4y. Step 2. Add or subtract the like terms and give the simplified expression. Pay special attention to the signs of the coefficients. 8x minus x gives 7x. 30y minus 4y gives us 9y. Therefore, we have 7x plus 9y. 3. Simplify the expression by collecting the like terms. Minus 2x minus 3y plus 5 plus 10x minus 3 minus 2y. Step 1. Rearrange the terms so that you group all the like terms together. Keep the sign in front of each term. Minus 2x plus 10x minus 3y minus 2y plus 5 minus 3. Step 2. Add or subtract the like terms and give the simplified expression. Pay special attention to the signs of the coefficient, especially subtraction sign. 8x minus 5y plus 2 after the normal arithmetic. Working with brackets in algebraic expressions. We sometimes use brackets to group terms or to separate entities in algebraic expressions. As we know, 2x means 2 times x, which also equals to x plus x. If we replace the x with x plus y, then in the same way, we will have 2 into the bracket of x plus y, which also equals to 2 times into the bracket of x plus y. We can use repeated addition to work out any multiplication. For example, 2 times into the bracket of x plus y equals x plus y plus x plus y. We need to remove the brackets before we can collect the like terms and simplify the expression. X plus y in brackets plus x plus y in brackets. Removing the bracket, we will have x plus y plus x plus y. Therefore, collecting like terms, x plus y equals 2x plus 2y. How do we deal with negative signs before brackets? We have only worked with brackets with a positive sign in front of them. When a negative sign precedes a bracket, it affects all the terms inside the bracket. For example, 10 minus into the bracket of 2 plus 3. We can simplify it as follows. 10 minus into the bracket of 2 plus 3 equals 10 minus 5 equals 5. This is the same as 10 minus into the bracket of 2 plus 3, which equals 10 minus 2 minus 3. In this case, the minus sign will be affecting the plus sign in the bracket. Minus times plus also gives minus. Therefore, we have 10 minus 2 minus 3, which equals 8 minus 3, and the answer is 5. It is not the same as 10 minus into the bracket of 2 plus 3, which will give us 10 minus 2 plus 3 equals 11. The symbol there means it is not equal to. So if we remove a bracket with a negative sign in front of it, we change the signs of all the terms inside the bracket. Here are some typical examples. 5a minus into the bracket of 2b plus c equals 5a minus 2b minus c. 4x minus into the bracket of minus y plus 2z equals 4x plus y minus 2z. Remove the brackets and then simplify the following expression. 2 into the bracket of 4m plus n minus 5m plus 3n in brackets. Step 1. Use repeated addition to work out the multiplication of brackets. 2 into the bracket of 4m plus n minus 5m plus 3n in brackets equals 4m plus n plus 4m plus n minus 5m plus 3n. Step 2. Remove the bracket. If there is a negative sign in front of a bracket, change the signs of all the terms inside the bracket. 2 into the bracket of 4m plus n minus 5m plus 3n. Then we have 4m plus n plus 4m plus n minus 5m plus 3n. Opening the bracket, this gives us 4m plus n plus 4m plus n minus 5m minus 3n. Step 3. Collect like terms and simplify. This gives us 4m plus 4m minus 5m plus n minus 3n. 4m plus 4m minus 5m gives us 3m. n plus n minus 3n gives us minus n. Working with brackets using the distributive law. When we have an expression with brackets, we know we need to multiply. When we do multiplication, we say that we expand the expression. From the examples and exercises in the previous slide, you can see a shorter way to multiply the expressions than repeated addition. The more straightforward way is to multiply the bracket's coefficient by each of the terms inside the bracket. When we do this, we are applying the distributive law, which states that 4 times 3 plus 2 in brackets equals 4 times 3 plus 4 times 2. In other words, 4 groups of 3 plus 2 in brackets are the same as 4 groups of 3 plus 4 groups of 2. So the 4 times can be distributed across the 3 plus 2 to get 12 plus 8 equals 20. By now, you know that 2 into the bracket of a plus b equals 2a plus 2b. Note that the bracket is seen as one package and can be replaced by one variable. Therefore, the expression 2 into the bracket of a plus b has one term, but expression 2a plus 2b has two terms. Quantitative problems on the use of brackets. For example, look at the two rectangles shown in this image. There are two ways in which we can write the total area of the two rectangles. Method 1. Calculate the area of each rectangle separately and then add the areas. Area of a small rectangle equals A equals 3 times 2 square units. This can be seen in the image. Area of larger rectangle is A equals 3 times 4 square units. The total area of the two rectangles, A equals 3 times 2 plus 3 times 4. This gives us 6 plus 12, which equals to 18 square units. Method 2. Calculate the total area of the combined rectangle. Width of total rectangle is 3. Width is also known as breadth. Length of total rectangle, 2 plus 4. Total area of the two rectangles is A equals 3 times 2 plus 4 in bracket. This equals 3 multiplied by 6, and this gives us 18 square units. From this practical example, we can see that 3 times 2 plus 4 in bracket equals 3 times 2 in bracket plus 3 times 4 in bracket. We have come to the end of today's lesson. Attempt these questions to assess yourself. How many terms do each of the following algebraic expressions contain? 1. 2x plus 12. 2. Minus 3 plus 7yz plus x. 3. 8 times p. 4. 3 times 7x times 5y times minus 1. Write the following expressions in a simpler notation. 1. X plus x. 2. 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. Simplify the following expressions. 1. 2h plus 3h. 2. 18p minus 16p. 3. 9x minus 10x. Remove the brackets using repeated addition and then simplify. 1. 2 into the bracket of h plus m. 2. 3 into the bracket of p plus k. 3. 2 into the bracket of a plus 2. Remove the brackets and then simplify. 1. 3k minus into the bracket of 2p plus k. 2. 2h plus m minus into the bracket of m plus 2h. 3. Minus into the bracket of 4x plus 3y plus into the bracket of 2x minus y. And 4. 3 into the bracket of 2 plus a minus 4x. Thank you for learning about the simplification of algebraic expression. See you in our next video. Bye.